She's a Mona Lisa. Know you're clutching hands and feet like how I switch gears. Only difference is I'm silent. Suddenly.
Okay, hi, my name is Naswana Bitrasi. My matrix number is CE190238. I start this presentation with introduction, which I will explain the background of the project. Alright, background project. First, an induction motor or asynchronous motor is an AC electric motor in which the electric current in the rotor needed to produce torque, which obtained by electromagnetic induction from the magnetic field of the stator winding. An induction motor does not require mechanical commutation, separate excitation, or self-excitation for all or part of the energy transfer from stator to rotor, as in universal, DC, and large synchronous motor. Second, the induction motor is widely used in industry due to its simple structure, low cost, robustness, and stable characteristics. In recent years, the induction motor has often been used for speed control. Third, in the characteristic analysis of induction motors, an equivalent circuit such as the based on the D to Q transformation is often used. This method simplifies the equivalent circuit, which help in understanding the state of the induction machine. And lastly, when speed control is applied to an induction machine by vector control using an inverter, the stator current or the rotation, which is slip, is usually detected, and the flux vector or the torque vector is estimated. It is very important in such a case to determine how the observer, which is estimation algorithm, should be formulated with the detect stator current or the rotation, which is slip, as the parameter. That's all from me. Thank you.
Assalamualaikum, my name is Nazula Binti Ashik. My matric number CE190064. So today I will present the methodology of this project. This methodology consists the procedure of modeling work in Microsoft Excel. Second, choose parameters and calculation. Third, the processes in obtaining the torque speed and power speed characteristic, and lastly the performance analysis made on the motor model. For the second stage is the procedures of modeling work in Microsoft Excel. In this step, the specific value of parameters chosen to represent a 50 Hz Y connected one rotor three-phase induction motor and the losses of the induction motor. The flowchart shows the step to plotting the power speed characteristic of the induction motor. First, we start to develop the instruction given by choosing one specific value for each parameter that required in this project. Then, we develop the induction motor model in Microsoft Excel with the chosen parameter. Next is calculate the output from the given information, plot the power speed characteristic of the induction motor in Excel, and lastly, determine the total efficiency of induction motor in percentage. Next is the manual calculation of induction torque speed characteristic. So, this is the parameter and variable that we choose. For slip is 0.035% and frequency is 50 Hz. Calculate the induction of torque speed characteristic. We need to calculate by using the Thevenin formula and impedance. Then we calculate the torque versus speed by using the rotor induced torque. Lastly, we plot the torque versus speed, and from here we can find the starting torque, pull up torque, and pull out torque of the motor. For induction power speed characteristic, in order to find the power speed characteristic, first we need to calculate the torque by using the Thevenin formula and impedance, same as torque speed characteristic. Induced torque we also calculated by the same formula, and then we find converted power by using the formula. Then we find the output power and get the value of the output power. We continue to find the efficiency power, which is the value that we get is 89.52%, and lastly we plot the power versus speed, and from here we can get the maximum output power. Next is for the third stage, the process in obtaining the torque speed and power speed characteristic. Typical torque speed curve of a squirrel cage induction motor given in figure shown provides information about the operation of induction motor. The induced torque of the motor is 0 at synchronous speed. The curve is nearly linear in normal operating conditions, which are between pull-out speed and synchronous speed. Maximum possible torque the machine can induce is called the pull-out torque or the breakdown torque, and it limits the short time overload capability of the motor. So for the last stage is the performance analysis made on the motor model. The analysis of performance motor model is we analyze calculation result, and the result that we choose to find the output power by subtract with the losses of the induction motor with the value given. Then we find the impedance, line current, and input power. Finally, we find the motor efficiency by using the value we get in the output power and the input power. That's all from me. Thank you. So I will pass to the next member to present.
Okay, hi, my name is Nurhani Salihah binti Narijan. I will explain my part, which is result and analysis. So for this project, we use Microsoft Excel to run the simulation. So from the Microsoft Excel, this is what we get. This is the graph. So for this project, we use synchronous speed, torque speed characteristic, and power speed characteristic. This is the formula that we use in the Microsoft Excel. So as we can see, this is the Microsoft Excel. So I will open the Microsoft Excel. So this is the value of parameter that we have been choose. So we put into the Microsoft Excel. As we can see, this is all the information that we can get. All the information is in this Microsoft Excel. So we have sleep and synchronous, current, voltage, torque, and so on. So here are some graph to see how the pattern is, and this is the two pattern. This is the torque versus speed, and this is the power. So for the torque, we use this value at the y-axis. So for the x-axis, we use this value. So for if we want to find the values here, we need to put the equation. So after we put the equation, it will continue the new value, as you can see here. So we find there is no difference from this Microsoft Excel and the manual calculation. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nur Ansyahira binti Abu Bakar and my metric number is CE10222. Today I will explain about importance of electrical machine in current technology. Before we go further to the topic, firstly we need to know about electrical machine. Electrical machine is a device that converts mechanical energy to electrical energy. There is two different types of electrical machine. Firstly, static and dynamic. Static electrical machine is such as transformer, and dynamic electrical machine is motor and generators. Now we go to the importance of electrical machine. Firstly, important component in many industrial applications such as power system, manufactories, power plant and others. Next, important use in our daily life. As we know, everyday items that we use are very closely related to electrical machines such as washing machine, blenders and vehicle. Third, increase the country economic. And lastly is improving the standard of human life, which is we can apply the things that contains of many electrical machine, and we can emphasizing the importance of electrical machine to others. So that's all for me and thank you.
Okay, in conclusion, in this project, we are able to obtain the torque speed and power speed characteristic of induction motor in order to predict the behavior of electric motor during its operation with load change, and to explore the main characteristic and efficiency of an induction motor in operation with the change in load. We also be able to demonstrate the main electrical characteristic of induction motor based on the combination of theoretical approach and simulation induction work. The torque speed and power speed characteristic of induction motor can be implementation by doing this task and plotting the graph in Microsoft Excel. By doing this project, we also acknowledge more about the importance of electrical machine in current technology trends. That's all from our crew. Thank you.